Hey everybody, this is the CER video answer key for PS2 Learning Set 2. This is for the CER Mini number 2. This video may look very similar to one that you may have watched recently, but it is slightly different. The last one I produced was a guide. It kind of guided you or nudged you through what to write, how to write the CER, what to put, but it wasn't an answer key. You couldn't watch the video and just simply copy down off the video onto your retake. So it was a retake guide. So this is the actual answer key. So what we're going to do is we're going to go through this in class, or if you're watching this video, maybe going through, you may be doing this at home or online if you're not in class that day, or you might be doing it in class if you weren't here on the original day. But this is going to guide you through what you should have written, and this is going to be considered a practice. So the next test you take, CER test, will likely be an actual test. So remember a claim. The biggest thing to remember is claim is just one sentence. So sometimes people will have a whole paragraph for the claim. No, just one sentence. And remember, when you're taking a CER test, if you look over on the wall, I have the CER posters. Now, the only time the posters may not be up is if we are going to be taking the state test. I take them down for that test because I don't feel comfortable having them up during the testing, even though I think they would be all right. I just don't have them up just in case. Here we go. Let's get going. So you were supposed to make a claim about the relationship between KE and mass. Then you were supposed to write the CER defending that claim with evidence and then use appropriate scientific principles. So keep in mind here it says use appropriate scientific principles. And we'll come back to that in a little bit. So here's your data. The light can, 170 grams. Notice up here it said the drop height for both was 30 centimeters. So this shows you that the 30 centimeters was a control. So the only thing we changed was the light can, which was 170 grams, and a heavy can was 425 grams. Everything else was the same. The thickness before was the same. However, look afterwards. The light can, when we dropped it, only produced 3 millimeters of squish. The heavy can only produced 7 millimeters of squish. So after looking at this data, you should have been able to answer the above, make a claim about the relationship between kinetic energy and mass. So you should have been able to answer that. So the relationship between kinetic energy and mass is, so notice I just copied this from up above. And get into that habit. It's the easy thing to do. It's kind of like your sentence starters from your book. It's a good way to have a sentence starter. The relationship between kinetic energy and mass is that the greater the mass, the more Ke you have. And you could word it differently. You could have said the greater the mass, the greater the Ke. You could have also said, look, if you have the relationship between kinetic energy and mass is that the lower the mass, or the smaller the mass, the less Ke you have. That would have been perfectly fine. The opposite is also true. So this is the bare minimum that you need to have for proficient. If you want to have an advanced, you might want to add in there if speed stays the same, if speed's constant, if everything else is a constant. So that's always a good thing to have. Now what you have to do is you have to sift through your data. And the big word I want you to take out of here is quantitative. You have to have some data numbers. You have to, if they're there, you need to delve back into the numbers and you need to put this evidence. So some people, when they would look at this right up here, they would just say, oh, 3 millimeter, or they wouldn't say 3 or 7 millimeters. They would just say, oh, the heavy can had more squish than the light can. Or some people would say, well, just look at the data table. Well, I can look at the data table, but what I want to figure out here is, can you look at the data table and pull out the data that's relevant, that helps you meet your claim? So I know there's a data table here, but can you sift through the data and figure out what's important? So again, I just put the bare minimum. This is the bare minimum you needed to have for a proficient score. The light can, 170, well, I'll be honest with you. I don't even think you need to have 170 and 425. If you would have just said the light can had 3 millimeters of squish and the heavy can had 7 millimeters of squish, I would have been fine with that. That 170, 425, it's nice to have, not necessary. Now, will that give you an advance if you have that? No. If you want to have advance, you'd have to talk and bring in all these numbers. And some of you did on the actual test. Some of you were a little off, but some of you didn't have any numbers whatsoever. So make sure you have numbers whenever relevant. So that's the evidence. Now, the reasoning This shows you how or why the data counts as evidence to support the claim. In other words, you need to link that, you need to find the evidence and you need to link it back to the claim. The other big thing here is you have to use scientific principles. Again, if you look at the posters on the side wall, you'll see that, you have to use scientific principles. And if we go back up to that initial slide, it says you have to use scientific principles. So if you don't use scientific principles, it's an automatic developing or lower. So make sure you use scientific principles. Now, let's look at the scientific principles. When you look through the 5 choices that you had, only one of them mentioned both KE and mass. Now I might say, well, no, Mr. Wattoon, this one had mass and this one had amount of KE, but look at it. An object's kinetic energy increases as its speed increases. No. So it mentions mass, but it's really not about mass, it's about speed. This one, an object's kinetic energy increases as its mass increases, as long as the speed stays constant. So this is the one you need to use. Some people use the first one. Well, yeah, it has KE, but that doesn't explain the relationship between kinetic energy and mass. And the last two both talk about gravitational energy, which had nothing to do with this one. It talked about kinetic energy and mass. So number 3 is the only one that truly fits best here. So remember when you're writing a CER and you're doing your reasoning, there's 4 things I'm looking for. I'm looking for you to restate the claim. Do you have the correct scientific principle or principles if more than one match up? And then can you explain how that scientific principle connects the evidence back to the claim? And then have a concluding sentence. So we've gone over this same slide multiple times this year. So a big, red sign goes up when I am grading your CER and I only see one sentence. I'm not going to say it's impossible to write this all in one sentence. It'd just be very, 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 very difficult to do given the CERs that I put out there. So you have to have multiple sentences. You need to have all these parts, and you have to have scientific principles. Those are the 2 biggies. So here's what I came up with. The relationship between kinetic energy and mass is that the greater the mass, the more KE you have. Now, does that look familiar? It should look familiar. It's the claim that we saw up here. All I did was copy and paste it. And that's the beauty of doing this online, is you can just copy and paste that from up above. Then I put in here scientific principle number 3 states that an object's kinetic energy increases as its mass increases as long as the speed stays constant. So does that look familiar? It should be. It's right from here. All I did was copy and paste it. Now I did add a few words at the beginning. SP number 3 states, and I've talked about adding this into all of your scientific principles. So or your CERs, your reasoning sections. Because by doing this, it draws my attention to it. It's like, hey, this student is using scientific principle number 3. Sometimes it's pretty easy to find out because you copy and paste it and I can see that it's clearly there. But sometimes people will paraphrase it or shorten it, and I'm not quite sure if you used it or not because you reworded enough where I'm not 100% confident that you used the correct scientific principle. But by copying and pasting it and saying, hey, SP number 3 states, you draw my attention to it, and I definitely know you used a scientific principle. So here's the 3rd part. Explain how the scientific principle connects the evidence to the claim. Our data showed that the light can, 170 grams, had only 3 millimeters of squish, and that the heavy can, 425 grams, had 7 millimeters of squish. Does that look familiar? That is very, very, very similar to this. I added a few words to make it flow, but it's very close to this. So when I look at the first 2/3, well, the first 3/4 right here so far, I mostly copied and pasted from my own CER. So I want to put that out there. I copied and pasted from my own CER up above, my claim and my reasoning and my scientific principles. I didn't copy off someone else. I copied my own work. That you can do. So now here I have to explain it. Our data showed that the light can, blah, blah, blah. Okay, we had that. Notice how I say 3 millimeters squish and 7 millimeters squish. Big deal. Tied together. Therefore, again, I'm showing the connection here. Therefore, when the mass of the can increased, so did the amount of squish. Okay. What about KE? I haven't brought that in here. this is the next sentence, more squish was the result of more KE. So by adding that last part, I say, okay, if we have more squish, that means there is more KE. So that demonstrates to me that I fully understand and have brought back and said that, hey, this data supports this claim. And I brought it all together right here. So when you get to the reasoning, there's a reason why the reasoning is probably the hardest part, because you have to bring several things together. So big thing for the reasoning, you have to have multiple sentences, you have to have a scientific principle, and you have to connect that scientific principle back to the claim. Now the last one about the concluding statement, some people do a pretty good job in the first three of making that connection and wrapping it all up, but it's just a way to wrap things up. So, as always, if you have any questions about CERs, make sure you get help. It's easy to say can't do it, or it's easy to say I don't know what to do if you never ask for help. So I believe you don't know what to do, or believe you may not know how to write it, but then ask to get help so you can learn how to do that. So ask questions if you got them. Thanks.